Congratulations! You're almost done covering the essential IT infrastructure services involved in an organization. You're so close. You got this. In the last module, we learned about the software services used in an organization like communication software, security, and file storage services. Then we talked about platform services involved in organizations that build a software product. Finally, we learned about some of the servers that support those organizations like web and database servers. In this module, we're going to learn about the last major IT infrastructure service, directory services. It's the beginning of the end. Ready? Let's jump in. Have you ever looked up someone's phone number in a phone directory? Or used a directory listing at a shopping mall to find a specific store? A directory server essentially provides the same functionality. A directory server contains a lookup service that provides mapping between network resources and their network addresses. It's used to organize and look up organizational objects and entities, ranging from things like user accounts, user groups, telephone numbers, and network shares. Instead of managing user accounts and computer information locally on every machine, all that information can be stored on a directory server for easy access and management. The ideal enterprise quality directory server should support replication. This means that the stored directory data can be copied and distributed across a number of physically distributed servers, but still appear as one unified data store for querying and administering. Why is replication important? It provides redundancy by having multiple servers available simultaneously. So there'll be minimal disruption to the service in the event that one of the server explodes. Replication also decreases latency when you access the directory service. By having replicas of your directory server located in each office, you're able to answer directory service queries more quickly. The directory server should also be flexible, allowing you to easily create new object types as your needs change. Access to the information stored in the directory server database should be accessible from a variety of OS types and from the designated areas of the corporate network. Directory services are useful for organizing data and making it searchable for an organization. This is achieved through the use of a hierarchical model of objects and containers. The containers are referred to as organizational units, or OUs, and they can contain objects or more organizational units. This is similar in organizational structure to a file system. OUs are like folders which can contain individual files or objects for a directory service. OUs can also contain additional folders. The management benefits of this structure are pretty clear. Can you imagine trying to keep your music library organized if there was no such thing as subfolders? Crazy! This hierarchical structure can be used to convey additional information about what's stored within. Take your directory structure as an example. You may have an OU called users, which contains all user accounts. Within this OU, there could be additional OUs which represent the actual team structure of your organization. The users OU could contain additional OUs like sales, engineering, and marketing, which include the user account objects for the individuals that belong to these teams. This structure can be used to convey differences between these sub-OUs of users. For example, we could enforce stricter password requirements for members of engineering without affecting sales or marketing. Sub-members inherit their characteristics of their parent OU, so any changes made to the higher level users OU would affect all sub-OUs, including sales, marketing, and engineering. Someone with the responsibilities of a systems administrator, whether that's a system admin or IT support specialist, would be responsible for the setup, configuration, and maintenance of the directory server. This includes the OS itself, on which the directory service would run. Standard OS management tasks are involved here, like ensuring that updates are installed and configuring standard services. Other responsibilities include the installation and configuration of the directory service itself, so installing the service and configuring any related services. If multiple servers are used in a replication setup, this needs to be configured too. It's very likely that the hierarchy and overall structure of the directory itself would also be up to the sysadmin to design and implement. Well, that covers the high-level overview of what exactly a directory service is. We'll dive deep into more specific details later in this course. But for now, let's review some of the concepts we just covered with the short quiz. Then let's meet back at the next video where we'll do a more detailed rundown on how to implement directory services. Directory services became an open network standard for interoperability among different software vendors. In 1988, the X.500 directory standard was approved and included protocols like Directory Access Protocol or DAP, Directory System Protocol or DSP, Directory Information Shadowing Protocol or DISP, and Directory Operational Bindings Management Protocol or DOP. Alternatives to DAP were designed to allow clients to access the X.500 directory. The most popular of these alternatives was Lightweight Directory Access Protocol or LDAP. Since these are open standards for communication and access for directory services, a bunch of different implementations of these services cropped up. There are offerings from Apache, Oracle, IBM, and Red Hat, but we'll cover two in more detail later in this module. The first is Microsoft's implementation, which is referred to as Active Directory or AD. It has some customization and added features for the Windows platform. There are also open source implementations of directory services using LDAP. A popular example of this is OpenLDAP, which we'll also cover in greater detail. OpenLDAP supports a wide range of platforms like Windows, Unix, Linux, and various Unix derivatives. In addition to the server software, there are also client tools used for accessing and administering a directory server. Microsoft offers Active Directory Users and Computers, or ADUC, which works well with Microsoft's Active Directory Server. There are also other more open tools that can be used to interface with a lot of other directory server implementations. Along with clients for administering and managing a directory server, there are also client applications that can interface with and query a directory server. All major OS platforms support integrating into a directory server for login and authentication purposes. The advantage here is that this allows for centralized management of user accounts. We'll cover the details of centralized management in the next lesson, so don't worry too much about that right now. When looking at specific implementations for your directory server, you'll want to consider OS support. Not just the server that will be running the directory service itself, but also what OSs your client fleet runs and the compatibility or support for your directory services. You can read more about why this is important in the next reading.